So again, I'm calling them sides because in a square, all 4 sides are the same. And some people last class were like, well, I've always thought of rectangle or squares as length times width. If in your head you still want to think of it as length times width, it's the same. But we're just getting at the point that the sides are the same, so it's multiplying the same number by itself. So let's sketch ourselves an example in here. Draw yourself a square, and I want you to label the side length as 3.5 inches. So to get my area of this example, we're going to have side times sides, 3.5 times 3.5. So let's do a quick fraction review. Who remembers when I'm multiplying mixed numbers, what I need to do with those mixed numbers before I can multiply? Abby? Turn them into improper fractions. So to do that, I'm going to take my denominator 2, multiply it by my whole number. 2 times 3 is, plus my numerator 1 is 7. Do we remember doing that earlier this year? So 7/2 times, the other fraction is 7/2. They're the same number. Once I have it in this format, a fraction times a fraction, I can just multiply straight across. So 7 times 7 up top is 49 times. And 2 times 2 is 4. Anyone feel good about turning that back into a mixed number? Ask yourself, how many times does 4 go into 49? How many groups of 4 can I take out of 49? 12, which is 48. And then how many pieces are left over? 1. 12 1/4 inches squared is the unit we're going to use for area. Any area label is going to have a square whatever, square inches, square feet, square yards, square centimeters. If it's area, it's going to have that square on the label, not on the number, on the label. Lucas.
Why can't you do just 3.5 times 3.5?
Well, in this case, we could because a half turns into a nice decimal. Not all of our fractions are going to be that way. So we're going to just review, and we're using this as just review for fractions too, since we'll have state testing come up next week. So I want you to show me the fraction on this. Not all of them are going to be fractions. We're going to do whole number ones too. Aiden?
I don't know how you count yourself, what's with the end. There's two always be there because it's 2 dimensions.
Yes, because I'm multiplying. So essentially I did 3.5 inches times 3.5 inches. Inches times inches is inches squared. I multiplied the inches by itself twice. Yep, that's where that label comes from. All right, let's do rectangles. We'll do a little practice and then you can start your homework. So on a rectangle, our side lengths are no longer the same, so we can't call them side and side because they're not the same. So we can't call them the same thing. Typically, we label our longer side as the length and our shorter side as the width. So our dimensions that we use in a rectangle are length and width. And then on the inside of your rectangle flap, let's write out our area formula. It's going to be area equals length times width. I'm using that I'm using that cursive L so that it doesn't look like a 1. If I write a lowercase l, it kind of looks like a 1. We typically don't use capital letters for variables. We're using lowercase letters. Write it how it will look clear in your notebook. We typically do not, no. All right, the example we're going to use here is sketch yourself a little rectangle. This one I'm going to let you use calculators on because we're moving to decimals. Give it a length of 9.7 feet and a width of 3.2 feet. So for our area, we're going to do length times width, 9.7 times 3.2. Write that down and then plug it in. When you have an answer, raise your hand. Give me the whole decimal. I think it's one that ends. Lucas?
31.04.
Very good. 31.04 or 31 400 feet squared. Same thing, it's area, so square units. Questions? All right, I'm going to let you start on your homework. While I get it passed out, I want you to look at this problem and see if you can come up with an answer to it. has 4 problems that are whole numbers. They should go pretty quick. The back side has some fractions. They're going to take a little bit more time. Would it be helpful to do the first fraction problem together, area and perimeter, so you've got an example to look at? Yeah. All right, so let's look at number 5 on the back together. Oopsies. Area and perimeter. How do we find perimeter again?
You add all the sides times 1 length plus 1.
Yeah, we're going to add all the sides together. So let's start with this one. I'm going to write out my work. So you've got an example. You can copy this one down and you'll have one less to do at home. So area, let's start with that because we just talked about it's going to be length times width. So it's going to be 3 1/3 times 1 1/6. Just like we looked at for the last example, we cannot multiply until we turn them into improper fractions. So 3 1/3, we're going to do 3 times 3 is 9 plus 1 is, so this turns into 10/3 times 7/6. So 6 times 1 is 6 plus 1 is 7, so 7/6. At this point, I've got 2 options. I can multiply straight across, or I can look. Remember, we can simplify before we multiply, either up and down or on a diagonal. Does anyone see anywhere we can simplify?
Yeah.
Where? 10 and 6 are on a diagonal. I could, if I wanted to, simplify those. A lot of you preferred that method when we were doing fractions. Simplify on a diagonal, it makes these numbers smaller. So divide both of those by 2. 10 turns into 5, 6 turns into 3. So that, now when we multiply straight across, we get 35 over 9. How many times does 9 go into 35, Lucas? 3, which is 27. How many more to get to 35? 8/9. So 3 8/9. What was the centimeters? Good, centimeters squared. All right, now for perimeter, if you've already completed this or you're good, you're welcome to keep working on your own. You don't have to stick with me. I'm just doing this. If you wanted the fraction refresher, doing it together. But if you are like, I'm good, or I can go ahead, do that. All right, perimeter, we're adding all of the side lengths. So 3 1/3 plus 1 1/6 plus 3 1/3 plus 1 1/6. To add with fractions, anyone remember what I have to have? Common denominator. I don't need to turn them into impropers, but I do need a common denominator. So what can I make my common denominator of thirds and sixths?
No, 6. You times.
I'm going to make my smaller one bigger into sixths. So we're going to turn 1/3 into how many sixths? 2 sixths. So this is going to turn into, I'm just going to rewrite it here, 3 2 6 plus 1 1/6 plus 3 2 6 plus 1 1/6. Just centimeters for a perimeter, because it's like measuring, so it's just a distance. All right, add your fractions first. 2 6 plus 1 6 is 3 6 plus 2 more 6 is, bless you. 3 plus 2 is 5 plus 1 more 6 is 6 6. So all of those fractions actually turn into 6 6, which is one whole. So 1 plus 3 plus 1 plus 3 plus 1, 9. All of that adds together to give me 9 centimeters. So perimeter, I'm just putting that label, centimeters, yards, inches, meters. No squared. The only thing that gets squared is our area. Okay. You've still got a few minutes that you can keep working on this. The front side, if you want to start with the easier side, is going to be the front side because it's just whole numbers. The back side, like this one's going to take a little bit longer because it's got fractions, but you only got 3 of those. All right, off you go.